This is section 4, Hybrid Recommender Systems. In this video, we are going to explore and understand the hybrid filtering techniques. Roughly, we can picture an overall idea of this hybrid recommender, as it takes the best of 2 or 3 systems that is made of user inputs and report a recommendation based on a merging while analyzing the data over the process time that we will be seeing in more detail in a few slides. A system that combines content-based filtering and collaborative filtering could take advantages from both the representations of the content as well as the similarities among users. But it will combine its disadvantages as well. That is why the hybridization is often made of 2 or more models. While there are several ways in which to combine the 2 or more techniques, a difference can be set between these approaches. A hybrid approach combines the 2 types of information, while it is also possible to use the recommendations of the 2 filtering techniques independently. So the different outputs still be linear for the analysis and can be then combined based on its weight, scores, or ratings, as it will receive the highest weight, scores, and ratings respectively. We have clearly addressed the problems with these 2 types of collaborative recommenders in the past sections. I'm just going to mention them in this slide to have a strong perspective of the benefits while merging them. For the content-based recommender system, we have the content description, over-specialization, and the subjective domain problem. Also, for the collaborative recommender system, we have the early rate problem, the sparsity, and the gray shift. Let's see in more detail the hybridization techniques. In order to achieve a better recommender system, it is necessary to combine and merge the different types of recommenders we previously saw in the previous section to address and fix the weakness that each of them have as we conclude respectively. In general, we are going to merge the collaborative filtering and the content-based filtering to accomplish this hybrid technique. There are some additional factors that need to be taken in count, such as the domain and data characteristics, because based on this, which actually will depend upon the implementation itself. The different hybridization techniques are weighted, that the components are combined using the scores by a linear formula. By this means, the components are able to produce a recommendation score as they need to be combined linearly. Mixed. This hybrid is based on merging of multiple ranked lists onto one, as its components should yield some ranking list to be then mixed or on the score produced. Switching. It is based on the selection of confidence and criteria because it may have components that should have different performance with different situations. Feature combinations. The core components of this hybrid it is actual recommender and the contributing recommender, as the actual works with the data of the contributing one, as the contributing injects features of one source to another source of the component itself. Feature augmentation. It is the same feature combination hybrid, just changing its output as it generates features from its contributor but smaller and flexible than the feature one. Cascade. This hybrid is similar to the feature augmented techniques because it works on the first model and makes additional candidates with the other models to refine the scores. Meta level. This model uses the contributing recommender as inputs for the actual one. It supplies the actual recommender with additional features. A meta level contributing recommender provides a completely new recommendation space.